All right, we're going to look at section 10.3, hypothesis test for population mean. The objectives test hypothesis about a mean and understand the difference between statistical significance and practical significance. So, hypothesis test about a mean, we learn about the sample mean distribution in 8.1, and they're showing you how to compute a z-score, and when we have the sample standard deviation, we use the t distribution with n minus 1 degrees of freedom. And just like in 10.2, we have the different types of tests that we will use and some of the parameters that we got to follow with the sample mean or the population mean. So we can use the normal provided that the sample size is large enough, so n is greater than 30. Then the test we have is equal versus not equal, looking at difference. Equal versus less than, so left tail test, and equal versus greater than the right tail test. The test statistic, which is denoted by T naught, given by sample mean minus the population mean over sample standard deviation divided by square root of n, where we use the student t distribution, n minus 1 degrees of freedom, and we will find our critical value using the student t table. So throughout this section, you have several different examples showing you tests using the mean, looking at the p-value approach and the critical value approach. The same result, if the p-value is less than alpha, we will reject the null. If it's greater than alpha, we will not reject the null. Sometimes we have to look at normal probability plots and box plots to see if there's outliers. Using this robust procedure to verify normality, what you're looking for is roughly a straight line, and then there's no outliers. If there are outliers, we cannot use this. Several examples. So another thing they wanted us to note is the difference between statistical significance and practical significance. And so if you read through this, I'll just kind of point out the example. So statistical versus practical. So they have a survey about the commute time to work. It was 29.3 minutes. They reprogrammed the lights, and it said there's evidence that time has decreased. So they got a sample of 2,500 commuters, find that the sample mean was 29 minutes flat. So that's not a big difference between those two. Is there statistical significance that time has decreased at the alpha equals 0.05 level? So then we go through the test. They do the t statistic, find the p-value, go through at the alpha equals 0.05, and they conclude that it is statistically significant. So it tells you here, because the test statistic is less than the critical value, it falls in the critical region, we reject the null. So we're rejecting the fact that it's equal to 23.9 in favor that it is less than. So it says while the difference between 29.3 and 29 flat and 29.3 is statistically significant based on our level of confidence, it really doesn't have any practical meaning, because after all, 0.3 minutes, which is about 18 seconds, it's not really going to make a big difference with your commute time. So it says the reason we got these results is due to the large sample size. So the moral of the story is large samples can lead to results that are statistically significant, while the difference between the statistic and the parameter in the null is not enough to really be practical, to really say there's a big difference. So with that, we will jump into my math lab. So this is an overview of how to find the results using technology. You got the 84 Minitab, which we don't use, Excel, and StatCrunch.